Okay, example 4, question 2. Okay, we are given the question in a bit of a complicated language, but we will understand it step by step. L1, L2. What are these? L1 and L2 are two straight lines. The relationship between them is S, right? That is why L1, S, L2 is written. But this is a little hard to understand. What is the simple language that we use? We write that S. We used to write like this. But once we get used to the language of sets, we can shorten it to write like this. Okay? Don't get confused. Just practice. So L1, L2 will be in the relation S if and only if L1 is perpendicular to L2. This sign just means L1 is perpendicular to L2. Okay? Now, before starting this question, I want to introduce a little bit of a concept. Not about sets, not about relations, about straight lines. So if I ask you, draw a straight line, you say, that is very easy. Here, have a straight line. Okay, if I say, draw another straight line, you say, well, another straight line. Now, if I ask you, where did you draw these straight lines? You will say, on the board, or in your case, in the copy. But in mathematics, we say, any straight line is always drawn on a plane. Right? Any straight line is always drawn on a plane. See, we don't need the board, we can have our hands. See, this is a straight line, this is a straight line, these are all straight lines, this is a straight line. All of these straight lines is in the palm plane, right? So every straight line will always be on a plane. Now let's assume that these two straight lines are in a plane and that plane's name is called L. So assume that there is a plane and in this plane there are two straight lines L1 and L2 and this plane's name is L. Okay? I use L because it is written like that in your book, so it will be easier for you to understand and to compare with the book's example and my walkthrough. But if you want, you can use any other name. You can use P, you can use anything. I am using L here. Now let's come back to the question. We have to find out whether this S relation is reflexive, symmetric or transitive. Let's try to find out. We always start with the reflexive relation. Okay, in case of reflexive relation, we will not take two different lines. We will take only one line. Let's take one line. We can take L1, we can also take L2. In our previous example, we took the first number or the first thing. In this example, let's take L2. Now, L2 is a line. Is L2 comma L2 in the relation S? When will it be in the relation S? Only if these two lines are perpendicular. Only these two lines are perpendicular. Is L2 perpendicular to itself? Perpendicular means 90 degree, right? Is it perpendicular? No, it is 0 degree to itself. Therefore, L2 comma L2 will not be in the relationship. Therefore, S, this relation, is not reflexive. Okay? How do we prove this? How do we write this in the language of sets? Okay, how did we write this? As L2 perpendicular to L2 is not true, where L2 belongs to L. What is L? What is this capital L? It is the plane. Okay, generally we write a set here, right? Whenever we write belongs to this, we write a set. I am saying that L is a plane, then how can it be a set? See, a plane can have all sets of straight lines, right? That is why we are writing like this. Therefore, it is not reflexive on L. You can write this part or you can also omit this part. These are not important. You wrote this, this is important. Okay? Just like the language English or Hindi or Bengali, you don't have to speak perfectly. But if you communicate well, the other person, your teacher, will understand. Same for this language. Let's check if it's symmetric. So, L1, L2. Can this be in the relation S? Let's check. Let's say in my palm, this is L1 and this is L2. Now, these are what? These are 90 degree apart. So, they are, what do we call it? They are perpendicular. So, they can be in the relation S. True. Now, can L2, L1 also be in the relation S? See, L1, L2 was in the relation S. But L2, L1 is also perpendicular. Therefore, it can also be in the relation S. It fits our condition, right? If L1, L2 is in relation, L2, L1 is in relation, then it is symmetric. So see how we wrote it. As L1 is perpendicular to L2 and L2 is perpendicular to L1, so L1, L2 belongs to S and L2, L1 also belongs to S. Therefore, S is symmetric. Okay? We can now shorten it. There, we have shortened it. Guys, remember, this is just optional. You don't have to write like this if you have problems understanding. Simple language is always the best language. Write whatever you are comfortable with. Okay? Now, we will prove this is transitive or not. Let's take an example. Let's say I have this line L1. Now, I have another line L2 which is perpendicular to it. Okay. Now, I am taking another line which is also perpendicular to L2. Okay. This line's name is L3. Now guys, tell me, is L1, L2 going to be in the relation? What is the condition? Both have to be perpendicular. L1, L2 perpendicular. 90 degrees. See, 90 degree. So they will be in the relation. Tell me, L2, L3. Are they going to be in the relation? Well, perpendicular. Then they are going to be in the relation S. Now tell me, L1, L3. Is this going to be in the relation? What is the condition? L1 and L3 has to be perpendicular. Is L1 and L3 perpendicular? Do they have 90 degree? No, they have 0 degree between them. Right? The angle is 0 degree. So, is this going to be in the relation? No. L1, L2 belongs to S. L2, L3 belongs to S. L1, L3 does not belong to S. Is this transitive? No. Let's write it down. Look how I have written. As L1 is perpendicular to L2, L2 is perpendicular to L3, but L1 perpendicular to L3 is not true. So L1 comma L2 belongs to S, L2 comma L3 belongs to S, but L1 comma L3 does not belong to S, therefore S is not transitive. Now shorten it. So after shortening, it looks like this: L1 is L2, L2 is L3, but L1 is L3 is not true, therefore S is not transitive. This is short but confusing. The previous one was longer but very easy to understand. Guys, these questions are simple but they teach you the language of sets.